Welcome to my channel. We will be solving this exam. In the previous video, I did a couple of questions. So this is an exam, a past paper from May, June 2025, and it's section paper 4 for mechanics. So we already solved question 1, 2, and 3. So now we will try to do question number 4. Okay, so this is interesting. We have given three forces. The magnitude of 17, 34, and 51. And we need to find the magnitude of the resultant force. Okay, interesting. The angle is alpha and this is 90. And alpha is not known, but we are given the tangent of this alpha. Tangent of this alpha is given as 15 by 8. Okay, so you can imagine that there's a triangle, right angle triangle. Okay, and this is 15 and this is 8 and this is alpha. Okay, if this is the situation, then of course the tangent of alpha is sine cosine 15 over 8. Okay, so from this information, can we calculate the hypotenuse? Okay, so the hypotenuse is going to be 15 square plus 8 square, and that comes out to be 17. Okay, so now we know that sine of alpha is going to be 15 over 17, and cosine of alpha, that's going to be 8 over 17. Okay, this is very valuable information we will be using this problem. Okay, so when I add the x component of all three forces, it will give me the x component of the resultant force, right? So the resultant force is F and its x component is Fx. So that is going to be, the first force is 51, I would say. So 51 Newton into cosine of alpha, right? That will give me the x component of 51 Newton force plus 34 into cosine of alpha again. That will give me the x component of this 34 Newton force. Okay, plus 17 times cosine of alpha plus 90, because this whole angle is alpha plus 90 and I'm using its cosine. Okay, now remember, cosine of alpha plus 90, cos alpha plus beta mean cos alpha cos beta minus sine alpha into sine beta. 90-degree cosine is 0, so this is going to be minus sine of 90 is 1, so minus sine of alpha. Okay, so this is 50. Let me do it here, save the space. So 51. Now cosine of alpha, we know it is 8 by 17. Okay, so this is 8 by 17. Okay, plus 34 times cosine of alpha again it is 8 over 17. And this will become cosine of 19 is minus sine. So this will become minus 17 and sine of alpha. Okay, so this is 3, 17, 3 to 51. So this is going to be 24 plus 8, 17 to the, this is 16 and minus 17 time, and sine of alpha is 15 over 17. This will cancel. So 24 plus 16 is 40 and minus 15. So this is going to be 25, I believe. Let me double check. Yes, this is 25 Newton. Okay, I hope this is all clear. You can see that the x component of this is going to be positive, this is going to be positive, this x component is negative, which is correct, which is negative here. Okay, so this value, this makes sense. Those are all calculation. Now Fy, the y component of this resultant force, all these four forces, resultant force, yes. So that will be the y component of all these three forces. So it is going to be 51 into sine of alpha, and I will subtract this one because it is on the opposite direction, minus 34 into sine of alpha, and it's also going to be negative. So let's see how it goes. It is going to be sine of 90 plus alpha. Let's expand it. Sine alpha plus beta mean sine alpha cos beta plus cos alpha into sine beta. So 90-degree sine is 1. It is going to be cos alpha, and 90-degree cosine is 0, so it becomes 0. Okay. So this is going to be where are we? Yes. So since it is negative, I have to, it's in negative opposite direction, so I have to put it negative. So negative in 17 times. Uh, Here I will have to put cos of alpha. Okay, because I want to put this angle, sine of 90 plus alpha, so this will be cos. Okay, so let's simplify this thing. It is 51, and sine of alpha was 15 over 17. Similarly, minus 34, and sine of alpha is again 15 over 17. And minus 17 times cos of alpha is 8 over 17. So this would be 45 minus 30 minus 8. Okay, so this will be 15 minus 8 is going to be 7 Newton. Okay, I hope this is all clear. These calculations should not confuse you. Okay, now I'm going to find the magnitude of the resultant force. So that magnitude is going to be under the root fx square plus fy square, and this would be 25 square plus 7 square, and it came out to be 674 under the root, and this is approximately equal to 25.96 Newton. Okay, so you can see that the resultant vector, it has 25 Newton is x component and 7 Newton is the y component, right? So the resultant angle is going to be in the first quadrant. So it is easy to calculate. This theta is tangent inverse y over x, and y is 7 and x is 25. So this calculation gave me an angle of 15.64 degree. Okay, so I hope this is all very easy. Now, this part B, it has part B as well, yes. Okay, the force of magnitude 51 Newton. I think there was another part here. C. No, there are two parts, sorry. Okay. This the force of magnitude 51 Newton is replaced by a force of magnitude P Newton acting in the same direction. The resultant of those three forces now act in the positive x direction. Okay, the issue is that this force 51 Newton, this is replaced by some other force which whose magnitude is p. We don't know how much it is, right? But the magnitude of p is such that this the resultant of these three forces, it has no y component. The resultant is only the x direction. Okay, so it means the y component is 0, right? Okay, remember y component was, let me do this problem right over here because I don't want to go there. Okay, so remember the y component is this part B. So the y component, it was 51 into sine of alpha. minus 34 into sine of alpha and minus 17 into cos of alpha. Okay, so if this 51 become P and sine of alpha, we know that it was 15 by 17 minus 34, 15 by 17 minus 17 times 8 over 17. So this y component has to be 0 if there's only x component. Okay, I hope this is clear. So this is 15 over 17p minus this is 30 and minus 8 equals 0. It means p equals 38 and multiplied by 17 over 15. Okay, 38 times 17 over 15. So this comes out to be 43.07 Newton. We can approximate it as 43.1 Newton. Okay, I hope everything is clear. You understand everything here. Okay, so this was question number 4, part A and part B. Okay, now let's do question number 5. Okay, so question number 5 says a car of mass 1500 kilogram is traveling along a straight horizontal road. It is given that there is a constant resistance to motion. The engine of the car is working at 24 kilowatt while the car is traveling at a constant speed of this much. Okay, you see, ideally, if something is moving on a straight horizontal surface, right, then there should be no energy used to move it. Okay, because if it is moving with some speed, then it will keep moving with the same speed. But since there was some resistive air resistance and road resistance, so some energy is needed to keep it pushing. Okay, so that energy is given as 24 kilowatt. Okay, remember, work done is equal to force into distance, right? If I divide this equation by T, then work done, okay, yeah, work done by in a unit time is the power. And this is going to be force, and distance per unit time is velocity, right? So if you multiply force with velocity, you will get power. If you multiply force with distance, you will get work done. Okay, so we will be using this expression right now. Okay, so this resistive force, since applied force, this is applied power, it is being used only against the resistive force. That's why it is still moving with a constant velocity and the velocity is not increasing. Okay, so that force is going to be uh, power over velocity. Power is given as 24 kilowatts, so 24,000 watt divided by its velocity is given as 32 meter per second. So 24,000 over 32 gave me 750 Newton. So the resistive drag of the air is 750 Newton. Okay. Now the second part is a bit complicated. Find the acceleration of the car at the instant it is traveling at a speed of 36 meter per second speed. And the power, yes, and the power is increased to 28 kilowatt. Okay, so when the input power is increased, you can imagine that the car will be accelerating, its speed will be increasing, right? And when the speed is increasing, the drag force, the resistive force is also going to increase. Okay, so anyway, when it is traveling, when the applied power is 28 kilowatt and the speed is this much, the force given by the engine, it is going to be 28,000 watt divided by 36. So this is the force applied by the engine on the car, right? But there was a resistive force that was 750 Newton. We found it in the first section. The, the air resistance on the car is 750 Newton. So now this is the net force which is trying to push the car, right? Okay, now we know that the force is equal to ma and mass is 1500 and time acceleration. So we can find the acceleration from this expression. Okay, so this acceleration is going to be 28,000 over 36 minus 750 and divided by 1500. So let's do this math. Okay, so here I have 28,000 divided by 36 minus 750 and divided by 1500. So that comes out to be 1 over 54, which is 0.0185 meter per second square. Okay, so this is the acceleration of the car when the power input is 28 kilowatt and it is traveling at this speed. Okay, now the next part is that it is given instead the resistance of the motion of the car is this much when the speed of the car is this. Okay, when the engine is working at 20, as a constant, find the constant speed. Okay, remember I told you that the power is equal to force into speed, velocity, right? Now we are given that the resistance of the motion is to given is a function of velocity and it's given by this expression. So force is basically 340 plus 4v into v, and the applied power is given as 20 kilowatt. So this is 20,000 watt. Okay, so we need to solve this expression and find the value of v from it. Okay, so you can see this is going to be if I write the left side to the right, so this is going to be 4v square plus 340v minus 20,000 equals 0. Okay. So if I divide everything by 4, just to make things a little bit simple, it is v squared plus 85v and minus 5,000 equals 0. So quadratic formula v equals minus b plus minus under the root b squared minus 4a is 1 and c is minus 5,000. They become plus and 4 times 5,000 and divided by 2a, 2 times 1. So this gives me two values, 40 and minus 125, right? So of course the velocity has to be positive, so this does not make sense. So my answer is 40 meter per second. Okay, find the constants. We can add this speed. The drag of the air resistance will balance, and the car will move with a constant speed. Okay, so now question number 6. Okay, this is interesting. A particle P moves in a straight line starting from a point O at the time. Okay, yes. So the velocity is given by this expression. Okay, find the value of t when the velocity is 100 meter per second. Okay, so let's see. Okay, so 15 minus 2t and its square is equal to the velocity, and velocity is given as 100. Okay, so if I make square root on both sides, it's going to be 15 minus 2t equals plus minus 10. And if I multiply with negative, it is going to be 2t minus 15 equal again plus minus 10. So t is equal to 15 plus minus 10 over 2. So 15 minus 10 is 5. 5 divided by 2 is 2.2. And 15 plus 10 is 25. 25 divided by 2 is 12.2. So I got these two answers. Okay, if I try to sketch the velocity versus time, okay, try to sketch this form, this expression. So you see when t is 0, it is 15 square, which is, first of all, you can imagine that this is going to be a parabola opening up, right? So it has a shape something like this. And I know it will touch x-axis and just go up. Why? Because when t is 7.5, so 7.5 times 2 is 15, 15 minus 15 is 0. So at this time, the velocity has to be 0. Okay. And when time is 0, the velocity was 15 square, which is 225. Okay. And this is when velocity was 100. And this is the time when it was 2.5. Remember this answer? And this is the time when velocity was 12.5. Okay. So yes, according to this equations, when the velocity at 2.5 second and 12.5 second, the velocity is going to be 100 meter per second as given by this expression, is 100 meter per second. Okay, so find the time, find the value of time. Okay, so we did this thing. Okay, so these are our answers. Okay, now the part B says that show that there is a particular value of time for which the velocity and an acceleration of the particle are both zero. Okay, so remember, acceleration is the derivative of velocity, right? What was the expression for the velocity? It was 15 minus 2t squared, right? Just let me double check 15. Yes. Okay, so if I differentiate this expression of the velocity, it is going to be 2, 15 minus 2t, and the derivative of 15 minus 2t is going to be minus 2. So it is minus 4 times 15 minus 2t. Okay, so meters per second squared. So this is acceleration is given in terms of t. So if you know the t, you know how much is acceleration. Okay, and now this is very interesting. If you just look at these two expression for the velocity and expression for the acceleration, you can see that common term 15 minus 2t here. So when 15 minus 2t is 0, the acceleration is 0 and velocity is 0. Okay, so at 15 minus 2t is 0, it means t is equal to 15 by 2, which is 7.5 second. So at 7.5 second, both acceleration and velocity would be 0. Interesting. Now the C part of that, find the displacement again. This is interesting. Of P from O at that time, find that the other is 0. Okay. So basically, remember we have talked about this several times that if we are given the velocity time graph of a moving object, then the area under the curve will give you the uh, distance traveled or displacement, right? Okay, so from 0 to 7.5, when the velocity and acceleration both are 0, we have to find the total distance. So we need to find this area under the curve of this parabola and x-axis. This is the area we need to find out. And how can we find this? Let me do this over here. Should I do? Okay, it is easier to do it over here. So this is part C. So distance travel, it is the integral of the velocity from time t1 to t whatever, right? So applying this expression, velocity is 15 minus 2t and its square, and I need to integrate it from 0 to 7.5, right? Because this is the time when speed becomes 0. So I need to evaluate this expression. So what I will do, I have 15 minus 2t and its square. So what's the derivative of this thing is minus 2. So I will divide this thing by -2 and integrate it from 0 to 7.5 in dt. So it is minus 0.5 is outside of the integration, and inside I have a function power n into simple derivative, so it's going to be 15 minus 2t and power 3 over 3, and limits are from 0 to 7.5. Okay, I hope you have no problem with doing this integration thing. So this will be minus 1 over 2 and 3, that will become 1 over 6. Okay, and inside, when I put the upper limit 7.5, it becomes 0, because 2 times 7.5 is 15, 15 and 15 is 0. Minus, when I put the lower limit, this becomes 0, and I will have 15 power 3 here. Okay, so the answer is going to be 15 power 3 over 6. Okay, 15 power 3 over 6, and this comes out to be 562.5, and this is meters. Okay, so I hope everything is okay, you understand everything. uh, if you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.